What do you think are the odds that there is life elsewhere in the universe?
They must be high, and I'll tell you why. People say, well, have you found life yet? No. Well, that's like going to the ocean, this has been said before, taking a cup of water, scooping up and saying, there are no whales in the ocean, Here's my data, You need a slightly bigger sample. And so if you look at, for example, what we call the radio bubble, this is the sphere around Earth, centered on Earth, which is the farthest our radio signals have reached in the galaxy. And they're about 70 light years away. We've been transmitting radio signals inadvertently leaking into space for about 70 years. 70 light year radius sphere. Well, how big is the galaxy? Well, shrink that sphere down to maybe the size of a BB, and then the galaxy on that scale would be the size of this stage. That's how far our radio signals have traveled. And those aren't even the ones we sent on purpose. The ones we sent on purpose have traveled much less. So no, we haven't actually reached as far into the galaxy as we'd like before we would say definitively that there's no one intelligent living today. But here's some very simple facts. I can review them in 90 seconds. You look at the formation of the Earth and the earliest sign of fossil life. Subtract a few hundred million years at the beginning of Earth, when Earth was a shooting gallery. Earth was still accreting the birth materials of the solar system. It's hostile to complex chemistry over that time. Not fair to start the clock then. Wait a couple of 100 million years. Now start the clock and wait around and see when you have the first signs of single-celled life. At most, 400 million years. At most. Earth has been around for 4.5 billion? So Earth, without any help from us, with basic ingredients found throughout the universe, managed to create life, simple though it was. So, and Earth, one of, 8 planets, get over it. Earth, an ordinary star, to suggest, and what are the ingredients of life? The number 1 atom in your body is hydrogen. Number 2 atom is oxygen, together making mostly water that's in you. Next is carbon in this order. Next is nitrogen. Next is other stuff. My favorite element, other, yeah. You look at the universe, the number 1 element in the universe is hydrogen. Next is helium, chemically inert, couldn't do anything with it anyway. Next is carbon. I think I left out oxygen there. Next is oxygen. Next is nitrogen, 1 for 1. We're not even made of odd things. The most common things in the universe are found here on Earth, and we're made of them. And carbon, one of the most chemically fertile element on the periodic table. It's not a surprise, we're carbon-based. Life is just the extreme expression of complex chemistry. So that's what biology is. So all these people who want to imagine, because they remembered their chemistry class that silicon sits right below carbon on the periodic table, so it bonds similarly to carbon, so they want to imagine silicon-based life. I'm saying, okay, fine, but you don't have to. There's 5 times as much carbon in the universe as silicon. There's no need to even have to go there. We got enough to imagine just simply with the carbon atom at the center of these huge biological molecules. Point is, it happened relatively quickly with the most common ingredients in the universe. To now say life on Earth is unique in the universe would be inexcusably egocentric.
Yeah, I agree with that.
Oh,
And I would go further and say that if ever you meet somebody who wishes to claim that he believes or she believes that life is unique in the universe, then it would follow from that belief that the origin of life on this planet would have to be a quite stupefyingly rare and improbable event. And that would have the rather odd consequence that when chemists try to work out theories, models of the origin of life, what they should be looking for is a stupendously improbable theory, an implausible theory. If there was a plausible theory of the origin of life,
It wouldn't be it.
That's right, because because then life would have to be
Everywhere.
Everywhere.
Yeah.
Now maybe it is everywhere. My hunch is that there's lots and lots of life in the universe, but it's probably because the universe is so vast, the islands of life that there are so spaced out that it's unlikely that any one of them will ever meet any other, which is rather sad.
It's sad. However, let me make you happy a little
Yeah.
bit more from that. We've learned now that we can model the formation of the solar system in this period of time where Earth was being bombarded heavily. That's called the period of heavy bombardment in the early universe. We call it like we see it in astrophysics. Let the record show. I don't know if I've ever in my life ever understood the title of a biology research paper. I just want to say that. Just the words, I'm not feeling them, you know? They're too big, too many syllables. I'm off topic here. So back to the period of heavy bombardment, and with computer simulations, you can model what happens when an impact hits a planetary surface. And it's not much different from if you sprinkle Cheerios on a bed, which you would never do on purpose, but your kids would do this. And then you smack the surface of the bed, there's a sort of a recoiling effect and Cheerios pop upwards. It turns out Mars may have been wet, we know at some point it had water, and fertile for life before Earth. And at this period of heavy bombardment, if it had started life, surely it would have been simple life. There's no reason to think otherwise. We've learned that bacteria can be quite hardy, as you surely know. So we imagine a bacterial stowaway in the nooks and crannies of one of these rocks that are cast back into space. In fact, if you do the calculation, there's hundreds of tons of Mars rocks that should have fallen to Earth by now over the history of the solar system. Maybe one of those rocks carried life from Mars to Earth, seeding life on Earth. My great disappointment would be going to Mars and finding Mars life based on DNA.
Yeah.
Then it would not have been a separate experiment in life. We would just all simply have to get over the fact that we are Martian descendants.
What we need is a second sample of life. We have only one at present. And
Why have you only given us one?
It would be a disappointment, as you say, if we found life on Mars based on DNA. Well, at least if we found life on Mars based on the same DNA code.
Sure.
Just about imagine DNA evolving twice, but you couldn't imagine the same four-letter code evolving twice. So, but I wanted to make a point that your calculation of it took only about 400 million years at the most for the first life to arise. For the first life capable of broadcasting radio waves capable of being detected elsewhere in the universe, it took approximately just under 4 billion years.
Yeah.
Well, no, about 4 billion years.
4 billion.
Which is about half the life that we can expect the solar system to
Sure.
exist.
Mm-hmm. An important point, by the way, because we were human before we had the technology to broadcast. So if your criterion for whether a planet has intelligent life, and if we are the measure of intelligence, then there could be plenty of planets out there with Roman empires and whatever else, and they're not sending radio signals. But any close enough observer would surely declare them to be intelligent.
The time interval between Roman empires and radio signals is negligible compared to the total time we're talking about. So it's an interesting question how long it takes once you get language, once you get civilization, once you get culture. How long does it take to get radio waves? Indeed, how long does it take to get self-destructive weapons that blow the whole lot up? I mean, that's the next.
And there's an implicit assumption that you're making inadvertently, possibly, that intelligence is an inevitable consequence of the evolutionary record. And I'm skeptical of that, because if that were the case, what we call our intelligence would have happened multiple times in the fossil record, and it hasn't. Whereas other things have shown up plenty of times, like the sense of sight and locomotion. There's some rather inventive ways things can get around the world. My favorite is the snake, of course. No arms, no legs, yet it gets around just fine. I'm imagining a alien visiting Earth, stumbling on a snake, the only creature it sees, right? And then it goes back and tells its home people, "You're not going to believe what I saw. There's a creature on that planet. No arms, no legs. It can still get around. It detects its prey with infrared rays and can eat things 5 times bigger than its head." And they'll think the guy was on drugs.
Yeah.
It's an ordinary snake sitting here on our Earth.
Yeah.
Another, just while I'm on the subject, big disappointment I have are Hollywood aliens. And I don't know who to blame for this, Hollywood or biologists that advise them. Hollywood aliens are way too anthropomorphic for me. Even E.T., he had a head, shoulders, arms. Okay, he had 3 fingers instead of 5. There's still fingers at the end of a hand. He had legs, he had feet. That's human. And look at the diversity of life on Earth to draw from if you want to think about the ways of being alive. I'm just so disappointed. And not even that I know that I can help them, but one of my favorite aliens ever was the Blob. Did you see that movie?
No, I don't see as many movies as you.
Blob is classic. It's just, so that alien was a blob, right? That's what it was. And it would just kind of move along and it would grab onto you and suck out your blood and keep moving. And it was non-anthropic in concept and it came from space. And I just thought that was an attempt to try to create some kind of way of being alive.
That's a very laudable attempt. It is interesting to look around the animal kingdom and count up the number of times that some things have evolved. I mean, eyes several dozen times, ears quite a large number of times. Echolocation, that's finding your way around by sonar, only 4 times. So that's
a bat and who else?
A bat, whales, and 2 different groups of birds, cave-dwelling birds. And a few rudimentary examples in some shrews and sea lions, but really 4 different times. Intelligence and language of the humankind only once, as you pointed out.
So it can't be that important for survival.
Well,
if natural selection is at work, it should have shown up many more times.
You'd think so. But I mean, it's a genuinely interesting point that I think biologists haven't thought about enough, is to go around the animal kingdom counting up the number of separate arisings of something, because that does tell you something about what you might expect elsewhere in the universe. You'd expect eyes. You might expect echolocation. Hypodermic syringes, stingers. About a couple of dozen. I'm talking about independent evolutions now. You look about spiders.
Our version of that would be called guns. Yeah.
Called what?
Our version of the hypodermic stinger would be called a gun.
Yes,
right,
okay.
To sting someone with
but I'm talking about something that penetrates the body and injects poison.
Yeah.
And that's an interesting question. And another relevant point is you look around the world at different island continents and say, how many times, how similar are they? You look at Australia, the Australian mammals, for example, and there are very, very powerful similarities between Australian mammals, which evolved entirely independently of mammals in South America, independently again of mammals in Asia and Africa. And so again, that gives you a kind of a clue for how predictable evolution is. Other worlds are going to be very different, but we perhaps shouldn't write off the possibility that the Hollywood aliens are they might not be that unimaginative. I mean, my colleague Simon Conway Morris has even suggested that it's very likely that there will be, if not humans, at least bipedal, big-brained, language-toting, hand-toting, forward-looking eyes for stereoscopy, pretty much humans. He thinks it's highly likely. He's got a religious agenda, I'm sorry to say, for that. But I, like him, I appreciate the power of natural selection. I think that whatever...
By the way, I think if he were... if he were a creature other than a primate, he might be giving a different list of things.
I think that's
matter.
right. Yeah, I think that's probably right.
The horse doesn't have 2 eyes facing forward, but the horse damn near can see directly behind it. And so the horse would be valuing that fact.
Oh, I'm not denigrating horses at all. I mean, there are lots.
I'm just saying that's your first sign that there's bias is you start listing the human features that you would want in an alien.
I don't want to say that I'm not picking on humans because they're superior, but because they're us. I mean, we have stereoscopic vision, we have 3-dimensional vision, horses don't. They have a different kind of vision, insects have a different kind of vision. Bats have echo. I mean, it's not vision, but it's using sound to produce what I would guess inside the bat's brain is probably perceived rather the same way we perceive visually, because why wouldn't you use the tools of the brain, of the mammalian brain,
to create an image,
to create a model of the world? I've even speculated...
By the way, that they showed that in, forgive me, the movie Daredevil.
Do they have bats?
He's blind, and when it rains, he likes when it rains because the rain hits people and he hears the different sort of reflections of the sound, and he saw his girlfriend for the first time in the rain. There's the image of her.
Okay, but my speculation is that bats hear in
It's
color.
America. I got to talk about our movies here.
My speculation is that bats hear in color. Because why wouldn't you use color? Color is just hue, perceived hue, is nothing more than a label that the brain uses.
Precisely. That's all it is. Yeah. Color, you attach it to some sequence of change phenomena.
And so bats would most usefully use color as a sign. For example, the difference between a furry moth and a leathery locust might be perceived as red versus blue. Mm-hmm. And that would be a very useful way for natural selection to have tied the labels of hue onto something that seemed very strange to us. But we're coming to the end of our time.
Didn't we just begin like a second
Well, that's
ago?
rather what I felt. If we want to have some time for questions...
Which I would very much like that, but I had a couple more bones to pick with you.
Okay, well, let's go quickly through those bones.
Okay. And just if you start formulating questions in your head. Some years, actually, 1994, was it? Or 1996, there was this rock in Antarctica, a meteorite discovered, ALH 84001, which had tantalizing evidence. By the way, that rock was from Mars, one of the tonnage of rocks that we know are out there. And there was evidence in one of the nooks of that rock for possible life, traceable not to Earth but from Mars. And so the evidence was very circumstantial but interesting nonetheless. There was chemistry there that could only happen in the presence of oxygen, and there was chemistry there occupying a similar spot that could happen only in the absence of oxygen. Now you might say, well, who cares? Well, life is just such a machine. When you breathe in oxygen, you oxygenate the hemoglobin. That oxygen gets used for your metabolism, and it goes back without the oxygen. In your same body, you have oxygenating and deoxygenating forces operating within you. So life does it for free. If you don't appeal to life, you'd have to have the rock hang out over here for a while and then roll down a cliff and go anaerobic for a while. You'd have to sort of patch it together. So it was all the news, page one story. And they even had an electron microscope photo of what looked like an itty-bitty worm. It had little segments on it. It was intriguing. That was not the lead evidence of the authors. It was just kind of interesting. It was about 1/10 the size of like the smallest worms on Earth, but interesting nonetheless. I'm invited to comment on this. In fact, it was Charlie Rose. He had 4 people. I'm the astrophysicist. They had a biologist. They had a philosopher. And the picture of the worm comes up. The biologist, who was piped in by a screen, said, "That can't possibly be life." So I said, "Wow, what have I missed?" So tell me, sir, why is that good? "Oh, because the smallest life on Earth is 10 times that size." And I'm still waiting for him to give me the reason why it can't be life. Then I paused and reflected and said, well, that is the reason he's giving me, that it can't be life. His comparison with life on Earth. And then I said, last I checked, we're talking about a rock from Mars. Why are you using Earth to constrain your capacity to think about what exists out there? My question to you, are biologists closed-minded or open-minded about what is possible in terms of biology in this universe? Because at the end of the day, you go behind closed doors and you confess to yourselves that you only have a data sample of 1, because all life on Earth has common DNA.
Yeah, well, he was being
and most any other sciences, we would say that's not, how do you make science out of
Sure.
a sample
Yeah,
of one?
no, that's right. He was being closed-minded, no question about it, because he was using his experience of life on this planet to make that generalization. On the other hand, one could make such a statement by using the laws of physics, and you could say that there are certain things that wouldn't work for physical reasons. I mean, I'm not saying that a tiny worm wouldn't work for physical reasons, but I could imagine somebody making an argument that said you cannot have, for example, maybe there's a certain minimum size of eye that could form an image for purely physical reasons, and that would be a good reason why one might.
And I'm there all the way.
Yeah.
It's just that he cited Earth as his measure of what is possible.
Well, he was just wrong.
Okay. Okay. You don't align yourself with his
I don't know who it was,
close-mindedness.
but
That was the biggest thing I had to get off my chest here.
okay. Shall we bring up the lights and see if there are...
There are microphones in the aisles, apparently, so if you just line up in the two center aisles behind those microphones, and I guess we can pick left and right for what questions you might have.
Professor Dawkins, we're very pleased to hear that you're writing a children's book on the beauty of science. We'd like both of you to write one for adults, or a video special on TV, because we don't want this wonder and awe that you all have been discussing today to be co-opted by religious people in the world, and it is really wonderful. So, what can we do to spread the word that science is not something to be afraid of? It's something to really be in wonder of.
Right.
Can I just slip in there? You commented that the book there's a children's book where you need one for adults. Indeed, we need one of those for adults. Interestingly, we probably don't need it for children, because children are born inquisitors of their natural world. They turn over rocks, they jump in puddles, they pour water down your back. They do things that are, you can look at it as wreaking havoc in the house, or you can look at it as a long series of science experiments. Some of them gone playfully wrong, but nonetheless explorations into the natural world. What happens is over time that gets beaten out of them, because that is not the behavior of the sign of obedience. That's the behavior of disarray. And plus adults far outnumber children. So I think the real problem in the world is adults, especially since they control the world, not the kids.
Yeah. I mean, what I would say about how we're going to convey the wonder, which you and I are both extremely interested in doing that, and following your mentor, Carl Sagan, for example. I mean, I like to make a distinction between what I call these two schools of why we should pursue the space race, space exploration. The non-stick frying pan way, which is it's useful because you get spin-offs like non-stick frying pans, and it's wonderful. And I go for the wonderful part, and I find that one of the problems with people who attempt to convey science to lay people, whether it's children or adults, is they tend to be obsessed with bringing it down to earth and making it ordinary and mundane and the sort of thing you might meet in your own kitchen. I prefer, and I'm glad somebody's doing that, but for me, I prefer the wide open spaces of space, the wonder of looking down a microscope at the very small, and thinking about it from a sort of more poetic point of view rather than from a more utilitarian point of view.
Right here, yes.
Hi. First, I'd like to say thank you. This is very stimulating, and it's wonderful to have this here at Crampton University, at Howard University, Crampton Auditorium at Howard University. I have a practical application question for technology and its impact on humans, specifically cell phones, cellular cell phones. I'm in healthcare, and I'd like to know where you stand on the effects. And I know we've come a long way since the first cell phones came out, but I get particularly apprehensive when I see young people putting cell phones to the heads of little infants and saying, "Talk to daddy," or something like that. That's my first question, the impact of the waves and things like that, which is out. I know I've looked at some studies on human beings. And then my second question is about the references for the origins of calculus in the Egyptian culture. Thank you.
Okay, given how many people are in line, I think we should try to answer as quickly as possible to do this, and I'll take a first stab, and if you want to try that as well. I don't know of any first efforts at calculus in the Egyptian culture, perhaps Richard does. And with regard to cell phone use, there's a very important fact of science, and that is the act of measurement. It's a fascinating thing, measurement, because you can never measure anything precisely. That is, with unlimited precision. You can only measure it with the uncertainties of your measuring device. And all you can do in the lab is try to constrain how uncertain that measurement is. But at some level, it will always be uncertain. And here's what happens. If you're trying to measure a phenomenon that does not exist, the variations in your measurement will occasionally give you a positive signal, as well as a negative signal. If that positive signal is the idea that maybe A causes B, in this case, cell phones cause cancer, a paper gets written about that result, and then people get concerned that cell phones might cause cancer or power lines might cause cancer. This goes way back. And so, in fact, if you look at the full spate of these studies, even those that they thought not to publish because it was not a positive effect, there's some cases where, in fact, there's less cancer. And so these are the phenomenon of a no result. When you actually have A causing B, the signal is huge. It is huge and it's repeatable in time and in place. With cell phones, that repeatable signal is yet to emerge from the total experiments that are done on it. That being said, if you're worried, almost every cell phone they have the cell phones on your hip and you've got an earpiece. So just do that if you're worried. But otherwise, I can either say the jury is still out or the experimental results are consistent with no effect at all.
I have nothing to add to that.
Okay.
About the
Sir.
calculus in Egypt.
So, can we have this one now?
Yeah.
Please?
Yes, I was interested when you were speaking about the bubble of radio waves as far as the limitation of our communication. I read recently at the Large Hadron Collider they've had some crazy experiments, but there are apparently particles that are seemingly unconnected, but they react to each other in symmetrical patterns of some kind. I'm very amateurish on this. But what do you think would be the possibility of instantaneous communication across vast distances using some kind of particle manipulation?
Yeah,
It's exactly an example of the kind of thing I meant when I said it's beyond me.
Yeah, so quantum physics is the physics of the world of the small. And in fact, quantum rules apply macroscopically, but they don't reveal themselves as exotically as what happens with single particles. And a particle can pop into existence, go out of existence, what we call tunnel from one place to another, instantly, with no time delay between the two. It could exist in all places at once, and then show up instantaneously here when you make the measurement. These are quantum rules that don't make any sense to us, because we don't live in a quantum world. If we did, these would be phenomena that would be quite natural. So now, can we exploit the quantum world for faster than light communication, is what you are suggesting here. And there's no known way to do that, given the laws of physics. In other words, you can have what's called a waveform, a wave function of a particle, and it's everywhere. You make a measurement, then the particle instantly shows up here, even though the wave had a probability of existing, the particle had a probability of existing over here. And so it's just odd, and we don't know how to exploit that fact to our advantage. But as far as we know, no, you cannot have faster than light communication, which we would desperately need to get bigger than the bubble to talk to the rest of the galaxy. Again, I'll try to make my answers even shorter than that. Yes, sir.
Making the distinction between life in the universe, which I think is inevitable, and intelligent life in the universe, which is, I question or challenge at least the probability of, given our planet being in the right location, the star being in the right type of star, in the right location, etc. What are the odds that you would, and given the time it took, 4.5 billion, 4.6 billion years, for us to get to the point where we can ask the question, is there intelligent life in the universe? What do you think those odds are?
The universe is huge in time and in space and in contents. So the good thing about the universe is extraordinarily rare phenomena happen every day, someplace in the universe. And so, however rare we might calculate it would be up here for life as we know it, you multiply up the numbers, the stars in the galaxies, galaxies in the universe, these are staggeringly huge numbers, 10 to the 21 stars, 1,000 times bigger than the number of grains of sand on an average beach. Itself 100 times bigger than the number of words ever spoken or uttered by all humans who have ever lived. These are staggeringly large, stupendously large numbers, to use Richard's word, that give us the confidence that even if intelligent life is only short-lived, grows up and then it becomes so smart it can kill itself, that there's bound to be one out there that we're hitting it right at the right time, that they are happy to have a conversation with us if we're smart enough to have a conversation with them.
This question is primarily for Professor Dawkins. I come from a family where there are 2 skeptics and 3 religious fruitcakes. You can guess which side I'm on. Anyhow, I was just wondering, with your experience, if you've ever found a good way to hit the fruitcakes upside the head with some rational thinking and actually get them to pay attention.
It would be nice to say that all we need to do is to expose them to scientific evidence. And that's certainly a very important part of it. It's what Neil and I are both trying to do. Unfortunately, there's a certain amount of evidence that there's a certain kind of mind which is so dyed-in-the-wool, wedded to a scriptural version of the world that they more or less admit in advance that no matter what evidence comes, they will refuse to budge. I mean, a good example, my favorite example of this is the geologist Kurt Wise, who is a young Earth creationist, but who knows very well all the evidence for an old Earth from geology. And he has actually said in these very words, I think I quote him approximately right, if all the evidence in the universe pointed to an old Earth, I would be the first to recognize the evidence, but I would still be a young Earth creationist because that is what Holy Scripture tells me. Somebody who's actually prepared to come out and say that, at least he's honest, somebody who actually comes out and says that is pretty much advertising himself as beyond reason. He's absented himself from the rational discussion which the rest of us are having by announcing in advance that Scripture is going to take precedence over evidence. And here's a man who knows the evidence. He has a PhD from Harvard in geology. He knows the evidence, and yet he's announced in advance. So there are certain people who are unreachable, but my hope is that the vast majority of people are eminently reachable and just simply haven't been exposed to the evidence which is plentiful and wonderful.
Next question here.
Thanks for the great job on the poetry of science. I wonder if you could say just a few words, both of you, on the philosophy of science. Just read Stephen Hawking's book, The Grand Design. First page, philosophy is dead. And here at Howard, our administration is proposing the abolition of our philosophy programs. Could you say a few words?
I have a couple of words to say about that. Up until early 20th century, philosophers had material contributions to make to the physical sciences. Pretty much after quantum mechanics, remember the philosopher is the would-be scientist but without a laboratory, right? And so what happens is the 1920s come in, we learn about the expanding universe in the same decade as we learn about quantum physics, each of which falls so far out of what you can deduce from your armchair that the whole community of philosophers that previously had added materially to the thinking of the physical scientist were rendered essentially obsolete at that point. And I've yet to see a contribution. This will get me in trouble with all manner of philosophers, but I call me later and correct me if you think if I missed somebody here. But philosophy has basically parted ways from the frontier of the physical sciences. When there was a day when they were one and the same. Isaac Newton was a natural philosopher. The word physicist didn't even exist in any important way back then. So I'm disappointed because there's a lot of brain power there that might have otherwise contributed mightily, but today simply does not. Philosophy has it's not that there can't be other philosophical subjects. There's religious philosophy and ethical philosophy and political philosophy, plenty of stuff for the philosopher to do, but the frontier of the physical sciences does not appear to be among them.
even in biology, I think is an interesting point that the idea of evolution by natural selection, which came independently to two traveling naturalists in the 19th century, it's a simple enough idea that any philosopher could have thought of it from the depths of an armchair any way back to the Greeks, and none of them did. And I don't really understand that. It seems to me to be a strange thing that it had to wait for two 19th century scientists living 200 years after Newton did something that seemed a lot more difficult.
Well, check Anaxagoras.
Sorry?
Check Anaxagoras, first theory of evolution in pre-Socratic Greeks.
Oh, well, okay. But natural selection is something that came in the 19th, not just to Darwin and Wallace. I mean, there were a couple of other scientists who thought of it. The philosophers that I really respect in the world today, philosophers of science, are ones who've actually taken the trouble to learn some science. And there are some. And they're very good, clear thinkers, and they do help other people to think clearly. But they're really the same as scientists. I mean, they're scientists who are also trained in philosophy.
Sure.
Thank you both for coming. There's a group of scientists in Europe that have developed a Large Hadron Collider, and they're trying to recreate the conditions of what has been known as the Big Bang, slamming antiprotons and protons together to try and find a particle known as the Higgs boson, which has been misnamed the God particle. It's a particle that gives matter mass. Could you guys talk about the conditions of the universe at that time? Will this prove anything, this experiment?
The interesting thing about physics is that there's very little physics left to be discovered on a tabletop. The way physics works is, the way discoveries in physics, by and large, work is, you need to go someplace you've never been before, either in scale, large, small, energy especially, speed. Once you explore these extremes, you are at the hairy, bleeding edge between what is known and unknown in the universe. So if you want to discover something you've never done before, build an accelerator that hits an energy level that's never been hit before. And the early universe is our best particle accelerator we know. And so now we have the very large tabletop version of the early universe, large and expensive, and it now allows us to test our ideas about what was going on. And so, yes, it's a regime of the early universe that we have theoretical understanding of, but we yet to have experimental verification for it.
I have visited the Large Hadron Collider twice, and on both occasions I was more or less literally reduced to tears. I was moved so much by this stupendous effort of human ingenuity, human cooperation, multinational, and I expressed my, attempted to express my poetic fascination and interest in this terrific enterprise in my latest book, and there was an unfortunate misprint. It came out as the Large Hard-On Collider.
That's just the D and the R, right? I guess that's...
I spotted the misprint, and of course I left it in, but alas, the publisher's proofreader also spotted it. She removed it. I begged her on my knees to leave it in. She said it was more than her job was worth.
It's a quick social comment. The 1990s canceled superconducting super collider that was to be built in Texas had peak energies 3 times as large as the Large Hadron Collider in Switzerland. Congress voted to not continue its funding. The project was scrapped, and now the center of mass of particle physics is no longer in the United States, it's in Europe. Now, interesting to the scientists, why we'd rather it be here in America, we really celebrate the fact that science continues to advance, and it's just a matter of whose nation's priorities values it. And I saw that as the beginning of the end of America's leadership in this realm.
Thank you. All right, thank you so much. I probably have a question which is rather mundane in this setting, but one doesn't get these opportunities very often. I recently thought about this. The life that's been discovered at the point of seafloor spreading on Earth is, I assume, because I haven't heard otherwise, also DNA-based, as is everything else we know of. And my curiosity is whether there is a hypothesis or an explanation that has been in fact devised as to how DNA can have this effect over the distance of 5,000 or 6,000 miles in the ocean itself between that point and the surface.
Not miles in the ocean. I mean, the diameter of the Earth is only you mean feet down?
I'm sorry.
Yeah, just the ocean bottom.
5 or 6 miles.
Yes, thank you. She said 1,000.
Exclude the 1,000.
Okay. I can give an astrophysicist view, but I'd welcome the biologist.
I didn't actually hear the question, so you start off by...
Sure. So these extremophiles, these are creatures that thrive under conditions that would kill the rest of us instantly. Under high pressure, high temperature. In fact, at the ocean vents, they're thriving at 300 degrees Fahrenheit. The pressure of the water is high enough to prevent boiling, but the temperature is high enough that it would cook anything else. One of the great advances in exobiology was the discovery that life on Earth is hardier than anyone had ever previously given it credit. We no longer need the room temperature pond water to have life thrive. The more we've looked in the Earth, the more we've found life doing the backstroke under extraordinarily hostile conditions, hostile to humans, that is. What that has done for us astrophysically is allow us to cast for life with a much wider net than we had previously thought we had available to us. Whereas before we would look in the habitable zone, the Goldilocks zone, not too close to a host star, your water would evaporate, not too far away, water freezes. You're looking for that liquid water zone, made liquid by sunlight. We find out all you really need is an energy source, doesn't have to be the sun. Jupiter keeps Europa warm, one of its moons. It has a liquid ocean, it's been liquid for billions of years. You want to look for life, armed with this diversity of life, the hardiness of life, even we find here on Earth, it has only broadened our search for life in the cosmos.
Among the many theories of the origin of life, recently people have started thinking about life might possibly have started under what we now think of as extreme conditions of high temperature. And it could be that we are now in the cold zone, which was not the way it was when it first started, and that's an interesting possibility.
So they would look at us like we're the extremophiles.
Exactly, exactly. They look at us as though we're the extremophiles.
I'd like to ask my question.
Well, my department chairman has said that he wants you to go ahead and ask your question. I'm not going to tell him no. So please ask your question. Keep it brief, and this is the last one before we go on to the book sign.
Thank you, Howard, for making this free. Anyway, I read a book, Constellation of Philosophy. The main guy, Boethius, is condemned to death. He has everything taken from him. All he has is his reason and his sense of self. Not even that. But he attempts to console himself to this execution by reasoning that the world has order, that there is something that keeps things together. And he uses his reason to try and get to the root of why he should be at peace at death. The problem is, his source of origin is a belief in God. What would you do?
Well, I don't know if I fully understand the question. I do know that if he's about to be executed...
How about you are about to be executed?
Oh, I'm about to be executed.
You have nothing except your knowledge and your knowledge of science, your experience.
I would request that my body, in death, be buried, not cremated, so that the energy content contained within it gets returned to the earth so that flora and fauna can dine upon it just as I have dined upon flora and fauna throughout my life.
What about you, Mr. Dawkins?
And I'm sorry, we have to move on. Please, another round of applause for Professor Dawkins and Dr. Tyson.